Hi everyone, today I'm going to talk about empirical formula, molecular formula, structural formula, and rational formulas. First, 6 types of pure substance you need to know. First one is ionic compound, which is a metal and a non-metal combined, like a NaCl or KOH, and crystalline element or compound, but it's only for non-metal, like the carbon or diamond. And metals like Au, Ag, Cu, and other things, okay? And the non-metal element, which is like O2, H2, O3. A molecular compound, which is non-metal and non-metals, like H2O, CO2. And polymers, okay, which is just a lot of things like starch, or the C2H4 and N. That means a lot of it. Okay, so chemical nomenclature. So first I tell the empirical formula, molecular formula, structural formula, and rational formula. Okay? Okay? And first, what is empirical formula? Well, empirical formula is a formula that they define all the coefficients by the same number. For example, like C2H12O6, okay? Maybe like glucose, okay? Or maybe fructose, maybe glucose, or if it's glucose, okay? So you divide all of them by 6, so it is CH2O. And or the benzene, which is CH, because they divide all of them by 6. But empirical formula, we think how? Why we use that? We just write in how much and how much. For example, remember ionic compound, crystalline element compound, and metals. So why is it used in those? Because I remember this free one is only use a small part of that to represent the whole. What does that mean? For example, ionic compound like NaCl, actually it's many NaCl for a cube to make one small salt crystal. So it's many NaCl, might be Na1000, Cl1000 in it, but we only use a few of them, only Na and Cl, to represent the whole. We divide all of them by 1000. Another crystalline element and compound, for example, elements like carbon. Carbon in maybe some carbon right here, there's a lot of carbon atoms in it. Maybe there's 1000 carbon atoms right here, so it is C100, but we only use a few of them. We divide all the coefficients by 100, so it will become C. Okay, so it becomes C, so we only said, oh, this is C. We don't say this is C 1100 or 1 million like that. And metals, for example, metal like for example, like this one. Okay, it's metals. So maybe most is make iron mostly, or other things. For example, like iron, okay? So there's many iron atoms in it, but we only use one iron to represent the whole things. For example, like Au is a metal, okay? So like Au, actually there's many Au atoms inside, but we only use one Au atom to represent the whole. Molecular formula. What is a molecular formula? Molecular formula is how much it tells you the number. For example, like C2H12O6 and C12H22O11. Okay? So, like C. How much C? There's 6. And how much hydrogen? 12. How much oxygen? 6. It tells you a number. So it's used in non-metal element like H2O. There's 2. H2, they tell you 2 hydrogen. And a molecular compound, wait a second, molecular compound like the H2O, they tell you like H is 2. And a non-metal element, which is like O2, O3, they tell you it's 3 or 2. And the polymers, you will think, no, polymers. So actually, it's an N, they tell number, but remember this C2H4 N. But there's a 2 and a 4, so we still consider it is molecular formula, okay? And structural formula. What is structural formula? Structural formula is it tells you the structure, so you can use the structural formula to know the structures and how much bonding, like this. And yes, and it can tell you the shape. And first, rational formula. So what is rational formula? So first, this is an rational formula. For example, like methyl ether and ethanol. Their molecular formula is both C2H6O, but their rational formula is different. It is CH3OCH3, and ethanol is C2H5OH. How to know it? So actually, the rational formula also tell you structures too. For example, like CH3, you can see right here, there's a carbon linked to 3 hydrogen, and CH3O, and there's in the middle O, and then another CH3. So it's CH3OCH3, like that. And this one, first there's 2 carbon right here linked to 5 hydrogen, so C2H5 and then linked to an OH, so C2H5OH. So it also tells you the structure. So this too is an isomer. So what is isomer? So first, what is isomer? Let's see. This one, isomers. Isomer, that means something that have the same numbers of atoms and the same element, but they have different structures, okay? And another, what is autotropes? Okay? Autotropes, okay? The autotropes, well, actually it's like where, for example, it's made of the same element but different structure, different structure. For example, like the charcoal, black lead, diamond, and all are made of carbon atoms, but they have different structures. So, what is isotope? Isotope actually is, for example, like isotope is something like the same. You think it's hydrogen, for example, it have deuterium and tritium. Okay, so they have the same number of protons but different number of neutrons. Okay, and then I am done. Bye bye.